students, today we are going to discuss exercise 10.3. The first question is, can a polyhedron have for its face 3 triangles? Now we have already learned that a polyhedron is a solid figure which has polygonal faces. So if you think of the smallest polygon with 3 sides, okay, that is a rectangle, sorry, that is a triangle. Now if you think of a prism with this triangular face, then we may have, what will you have? You will have a triangular prism. Okay, in a triangular prism you have 2 triangular faces, and what will you have? 3 sides will be, the lateral sides will be rectangular parts. Okay, so total it will have 5 faces. Okay, so one here, and all 3 sides 3 rectangles. So minimum 5 are needed. So here the question is, can you have a polygon with how many faces? 3 faces, total 3 faces, 3 triangles only, which is not possible. So with 3 triangles it is not possible. Okay. Now if you think of pyramid also, if you think of a pyramid, that is a triangular pyramid if you think of. So if you have this way a triangle, here you have a point, this will be the figure. There also base will be one triangle and all the 3 side figures. So total there will be 4 sides. So 3 sides it is not possible. The next question is 4 sides it is possible, 4 triangles. 4 triangles it will be a triangular pyramid. A square and 4 triangles, that is also possible. How will it look like? You can draw a square here, you may have a square, and then you can have this way figure. Okay. What is it called? It is a square pyramid. This will be the shape. So you can have a square and how many triangles? 4 triangles. So that is possible. So in the first case it is not possible, second and third case it will be possible. So first one no, and second and third will be yes. Now question number 2. If you take question number 2, is it possible to have a polyhedron with any given number of faces? When they say any given number of faces, it may be 1, 2, 3, 4 up to infinity, any sides. But we have just checked minimum how many sides are needed, or minimum how many faces are needed? 4 faces, because the smallest polygon on the base, if it is 3, that is triangle, and then 1 triangle on the base, and then you have 3 triangles on the side. So total 4 sides are needed, 4 faces are needed. So you cannot have polyhedrons with 1 face, 2 face or 3 face. So here how will you write the answer? Is it possible to have a polyhedron with any given number of faces? No, it is possible with 4 or more faces. So the answer is it is possible only with 4 or more faces. Now let us see question number 3. Which of the following figures or which of the following are prisms? That is the question here. Now if you see the first one, it is a nail. What is the shape you see? Does it have any two parallel planes? No. You can see one triangular face, one apex. So it can be considered as a cone, but it is not a prism. Now if you see the second figure, it is an unsharpened pencil which has two parallel sides. See here, one hexagon here and one at the back. So this can be considered as a prism, a hexagonal prism. Now if you see the third picture, that is a table weight in the form of a square base with 4 triangular side faces. So it can be considered as a pyramid, not as a prism. Okay. So third one is not a prism, but it is a pyramid. Now the fourth one is a box, cubical box or cuboidal box you can consider. It has got rectangular face on the top, so similar face will be at the bottom, and then it has got 4 lateral faces which are all rectangles. So this can be considered as a prism. So from the given 4 figures, second figure and fourth figure both are prisms and the other 2 are not prisms. Let us see question number 4. There are 2 questions. First question in that is, how are prisms and cylinders alike? Now you know in prism you have 2 flat surfaces and according to the number of number of sides the flat surface have, you will have lateral faces. Now for example, if you think of a triangle, so the triangular pyramid, triangular prism, the sides will be like this. Now if you increase the sides, it will be quadrilateral. Then you can have a pentagon. Okay. Then you have one hexagon. Now again, if you increase, you may have heptagon. Okay. Like this, if you increase the sides, many sides, infinitely many sides, slowly it will form a circle. Okay. When it forms a circle, it will become a cylinder. So how are pyramids and cylinders alike? In a pyramid, when you increase the sides, okay, when the sides get increased, it will become like a cylinder. Okay. So how will you convert, or how will the prism and cylinder look alike? When it will look alike? When the number of sides of the prism increases, it will, as it increases, it will become a cylinder. Cylinder looks like this, right? Okay. So slowly, if you increase more and more sides, it will become a circle here, and then it will look like a cylinder. The next question in that is similar question. How are pyramids and cones alike? Pyramids and cones also. Pyramids, they have any shape here, and then it form a, means they have triangular sides. So instead of 3, you may have 4 sides, and then okay, 5 sides, 6 sides. This base, this changes. Okay, it increases slowly. When it increases, then it becomes a circle here. Whenever the base, whenever you increase the number of sides of the base, slowly turn into a cone. Okay. Now the question number 5 is a square prism same as a cube? Explain. Now square prism means a prism in which the base is square shape. Okay. Sometimes the base will be square, but the sides may not be squares. So it will be like a cuboid. It may not be, see, if you have a cuboid, okay, if you take a cuboid, this side and this side, they may be square. So it is a square prism, but it is not a cube, it is a cuboid. So not compulsorily be a cube, it can be a cuboid also. So you can call a cube is a prism. Okay, cube is a square prism, but all square prisms are not cubes. It can be cuboid also. So how will you write the answer? Is a square prism same as a cube? Not always. Sometimes it may be a cube depending on the side, lateral sides. If the lateral sides are also lateral sides are also square, then it will be a cube, but not always a cube. Sometimes it can be a cuboid. Now question number 6 is verify Euler's formula for these solids. What is the formula? We have learned it yesterday. The formula is F, that is number of faces, plus V, number of vertices, minus number of edges is equal to 2. We have to find the number of faces, vertices and edges and substitute the values and check whether you are getting it 2 or not. Now see here you have a pentagon. When you have a pentagon, one face pentagon, so there will be another pentagon on the base. So 2 pentagons, one on top and one on the bottom. And if it is a pentagon, how many side faces it will have? 5 side faces. So 5 side faces and 2 end faces. So total 7 faces. Now how many vertices it has? You see down there will be 5. On top also 1, 2, 3, 4, 5 vertices. So total 10 vertices. Now how to find the edges? You see here on the top you have 5 edges, bottom also you will have 5 edges, and on the sides also 5. So total 15 edges. Now let us substitute it. F means 7 plus V means 10 minus 15. So what do you get? 17 minus 15, which is equal to 2. So it is proved. Okay. Similarly, another figure is given here. Here there is a square, and on top of that square prism there is a pyramid. So here how many faces? Down one face. Here there is no face. From there the pyramid is going out. So here how many? 4. And on this side 4. So 4 plus 4, 8, and 1 down. Total 9 faces. Okay. Now vertices if you count 1, 2, 3, 4, 5, 6, 7, 8 and 9. So total 9. And edges if you count, here 4 down, 4 side and 4 here and 4 on this. So total 16 faces, 16 edges. So you substitute 9 plus 9 minus 16, that is 18 minus 16, which is equal to 2. In both the cases, when you substituted the value, we got 2. So hence verified. So the question is verify Euler's formula. The formula is F plus V minus E is equal to 2. whenever such questions are there, you need to find the value of f, v and e, substitute it and then find out whether you are getting 2 or not. In this case, both the cases we got 2. So hence we have verified. Now question number 7 is, a table is given with the number of faces, vertices and edges. Now wherever the missing part is there, that you need to fill using Euler's formula. And what is Euler's formula? F plus V minus E is equal to 2. So here F is not given, 6 vertices and 12 edges. So let us substitute it in the formula. So you will get, F is not given, so we will write it as F plus 6 minus 12 is equal to 2. How will you write? F is equal to, we have to find out, vertices 6, edges 12 is equal to 2. So when you do it, here you get F 6 minus 12 is minus 6 is equal to 2, and then F is equal to 2 plus 6 is equal to 8. So the first case, faces is equal to 8. The second case, what is the question given? Face is given as 5. F is equal to 5 plus V not given minus 9 is equal to 2. So what is the question here? 5 plus V minus 9 is equal to 2. So what is 5 minus 9? See, V we will keep as it is. 5 minus 4, 9 is minus 4 is equal to 2. So V is equal to 2 plus 4, which is equal to 6 vertices. Okay. Now the third question is 20 faces and 12 vertices and edges we don't know, is equal to 2. See here, 20 plus 12. How much is 20 plus 12? 32 minus E is equal to 2. Now we have to find the value of E. So take E to that side and 2 to this side. So you will get 32. This 2 when it comes here, it will become minus 2. And E when it goes to that side, it becomes plus E. So E is equal to 32 minus 2, 30. Okay. Now the next question is, can a polyhedron have 10 faces? How many faces? 10 faces. Next question is, can a polyhedron have 10 faces? So how many faces it can have? In the question it is given 10 faces. So F is equal to 10. Then 20 edges. So E is equal to 20. And 15 vertices. So V is equal to 15. So the question is, can you have a polyhedron with 10 faces, 20 edges and 15 vertices? So let us see whether it is possible or not. What is the Euler's formula? F plus V minus E is equal to 2. Substitute these values. F is equal to 10, V is equal to 15, E is equal to 20. So when you work out, what will you get? 10 plus 15, 25 minus 20, which is equal to 5. Okay. So we got, instead of 2, we got here 5. So can you have a polyhedron with these measures? No. Since, how will you write since? F plus V minus E is not equal to 2. We cannot have a polyhedron with 10 faces, 20 edges and 15 vertices. So, what is the reason? When you substituted these values in Euler's formula, we did not get 2 answer. If you get 2 answer, then only it is possible. So, this was the last question in that exercise. So, with this chapter gets over. In the next class, we will start with another chapter. That's all for today. Thank you.